In a few minutes, I will be briefing on the topic soil stabilization techniques with prefabricated vertical drain. The purpose of the PVD technique is to stabilize and to strengthen the soil underneath. In this process, soil is stabilized through increasing the shear strength of this soil, and it increases the bearing capacity of the soil to withstand the load and infrastructures. And the second one is to reduce settlement time of soil to a considerable extent. That means, whenever this PVD is applied, it reduces the required settlement time of soil to a considerable extent. Thirdly, to reduce liquefaction hazards during earthquake. During earthquake, there may be possibility of increasing the pore water pressure during earthquake. So, through PVD we can reduce the pore water pressure by releasing the underground water, through it give the safety factor towards the soil. Prefabricated vertical drain structure generally consists of a filler layer and a synthetic drain layer. Filler layer, prefabricated vertical drain structure. PVD consists of a filter layer and a synthetic drain layer. This filter layer is made out of geotextile fabric, which is wrapped in the synthetic drain layer made out of polypropylene core. Now, the properties of PVD. The PVD, sometimes we may call it weak drains, shall meet the requirements as follows. The width of this PVD drain should be minimum 100 mm. The thickness of this PVD should be minimum 4 mm, and tensile strength should be greater than 2 kilonewton. Elongation at break should be more than 35%, and discharge capacity should be more than, it comes out nearly 1.3 cubic meter per day. Now, objectives of these techniques: to illustrate the installation and working of PVDs, to illustrate the installation of lateral drainage system, which is a part of this PVD also. Thirdly, to study the various advantages of this particular technique. And the fourth one is to understand the factors affecting the performance of the drains over the time period. Now, in brief, steps of installation. We have to first place the rig at drain location where we want to put the drain. Then we have to place the anchor on the drain end. Then through a hollow mandrel to this crane penetrate up to desired depth along with the PVDs. So, after reaching the required design depth, the mandrel is withdrawn, leaving the PVD at this level. After reaching at the level, the PVD drain is cut above drainage blanket. This is the pictorial thing of installation of PVD. Now, this is the graphical representation of steps of installation. The first one is placing this rig at the desert point where we want to place the PVD. Here one anchor plate is attached at the lower point. Then we should attach this PVD end at this anchor plate. After that, hollow mandrel, which is attached with these machineries, will keep on digging up to the desired depth along with the PVD. Now, after reaching the desired depth, the mandrel is withdrawn, leaving the PVD at this level. Now, after coming out of this mandrel on the soil, this PVD is cut. This is another pictorial representation, that is instrumentation of vertical drains. Now, you can see this OGL where this PVD has started to dig in underneath. There we place the settlement platform, that is settlement gauge, to measure the vertical settlement, and this bottom, the piezometer is also set up to measure the pore water pressure. After measuring the pore water pressure, accordingly what will be the settlement of this soil, that will be measured by the settlement gauge placed at the top of the soil, because with the settlement of the soil it will go down, and accordingly straightaway we can measure the vertical settlement. This is a typical layout of the PVDs. Now, this first one you can see, it is a triangular pattern, basically equilateral triangular pattern, and another is square pattern. D is diameter of the drainage influence. Now, if we compare in between the two patterns, this square pattern is very convenient to install in this land because it is very easy to install, and in the triangular pattern it is a little bit complicated, but it is useful considering the uniform settle point of view, because by this triangular pattern we can achieve uniform settlement of the soil. Now, a lateral drainage system. Strip drains are provided laterally under the such as to discharge flow from PVD laterally. Actually, whatever pore water or groundwater is coming out of the PVD drains, it is to be discharged at some suitable discharge points. It will be done through the strip drains, which is very necessary. Now, strip drains are connected with the PVD end above the ground, where strip drains are placed laterally. So, whatever pore water is coming out of the PVD drain, this strip drain will receive the flow of this water and it will discharge laterally at the edge of this surcharge. And during the lateral discharge, the strip drain should perform very well, so that there should not be any back pressure on the PVD, otherwise it will decrease the discharge capacity and it will result in consideration time. Now, this is a pictorial representation of the strip drain installation. The first one you can see, these strip drain are laid laterally, where the PVD end, wherever it was cut, that end is connected with this lateral strip drain. Whatever flow is coming, that is discharged laterally, ultimately at the edge of this surcharge. The right one is the schematic diagram representation. Actually, this strip drain is made out of the same material like PVD. Now, this is settlement graph of a soft clay showing significant time reduction achieved by applying PVD with surcharge loading. The upper one line showing without any PVD and surcharge. So, it will take long time to meet the required settlement time, because it is just too much extent parallel to the required settlement time. So, it will take long time to achieve the required settlement time. Now, the second line is shown as PVD without surcharge. It will also take long time, but it is less compared to the first one, that is without PVD. The third one is with PVD and with surcharge. You can see it is intersecting the required settlement graph at very nearer to this ordinate, that is the settlement time will be reduced enormously. So, here the advantage we can get through the application of the PVD with surcharge. Now, the advantage of PVDs, it decreases the time of consolidation and decreases the amount of surcharge required. Third one, it increases the rate of strength gain of soil. Now, the factors affecting the performance of drain. The discharge capacity decreases as time proceeds due to clogging of drain, because there may be possibility clogging of drain over a period just because of intrusion of some soil particles in the drain. So, that can be reduced if we use large drain. And the second one is bending / deformation of drain. There may be possibility of bending or deformation of drain after installation the same, because whenever soil settles down, it will give enormous pressure on the PVD drain. There may be possibility of bending of the same, and it can be deformed also. So, that can be removed if we use very flexible and durable PVD drain. Now, third one is punching of drain. Due to the lateral earth pressure, there may be possibility of punching of the drain, just because of filter media can pass into this synthetic core drain in a punching manner. Now, conclusion: by the PVD technique, we can reduce the consolidation time process very effectively, almost by 85 to 90%, resulting in reduction in the time required for the project to complete. The second one is consolidation process time can be further reduced by decreasing the spacing of PVD. Now the different pattern of PVD's installation may be adapted as per convenience and suitability. Thank you all.